Hi there, this is a screencast to basically demonstrate how we want you to analyze your data when you are gathering data on the hominid skulls for the last week of lab in Biology 1134 at the University of Oklahoma. So in lab, you're going to be measuring a set of morphological characteristics on a bunch of skulls of hominids. These skulls are casts of actual hominids, but in that, what you should be measuring is you should be measuring a bunch of linear measurements of different sorts of characteristics. For example, cranium breadth, cranium length, et cetera, et cetera. The foramen magnum distance from the back of the skull for all of these different species of primates, most of which are hominids of one type or another, and two of them which are different types of chimpanzees. The chimpanzees pan troglodytes and the bonobo pan paniscus. And so what you have is you have this data set, and then what you need to do is you need to save this data set as a CSV file. The way you do that is you just go up here to File, and you click on Save As, and this should be in a data set that is already named ST hominids. And when you save it as ST hominids, what you now need to do is save it as a comma delimited or comma separated values file, a CSV file, which is right down here. Choose that file type and save it, and that will allow you to now bring it into HHMI Data Explorer. So I'm going to close this for now, and I'm going to go to my browser, and you can just search for HHMI Data Explorer. And when you go to that website, it will ask you if you have any data that are in your queue. And what you want to do is you want to import your own data set. And so you click on that button, you choose the file that you want. So you go to wherever you stored your file, and you find that data file. Here it is. It's a CSV file. So the Excel file that I took it from is not able to be clicked on. Only the CSV file is available. And then you click Upload. And once it's uploaded, you should see it right there. And then you just need to click OK. And what it will do is it will open up. And you can see that you have your headers up here. And the example that is in your lab protocol has us looking at the earliest fossil date, expressed as millions of years, and since it's in the past, these are negative millions of years ago, and we're going to be looking at the foramen magnum index, which is in this column over here. So once you have your data in here, you can click on the Analyze tab, you can go to Add a New Analysis, and you want to go down to a linear regression. And once you click on linear regression, what you will see is you can identify the dependent variable, which in this case is the foramen magnum index, FMI. And then you can specify what the independent variable is. And in this case, it's time. And so we're going to choose the earliest fossil, the date of the earliest fossil, expressed in millions of years before the present. And once you do that, you see that it gives you the range of these values, and it will also show you over here in the lower right-hand corner, it will give you the model. And what this is basically telling you is that if you want to know what the foramen magnum index is, the equation of the line that relates foramen magnum index to the date of the earliest fossil is 23.28247 plus 2.22042 times the earliest fossil. 2.22 is the slope value of this regression, and you can come down here to this section here and you can see what the statistical test is. And what the statistical test is testing is what is the probability that this slope is different from a slope of 0. And it's the probability of that the slope is different from 0. And the p-value, once again, is the probability of you saying the slope is different from a slope of 0 when in actuality it is not. And so this is the p-value that you're looking for down here. So this is information that you can put into the section that asks you for statistical support for your conclusions. And so this is basically telling you that as time passes from early time to the present, the position of the foramen magnum has actually moved further and further forward underneath the skull, which indicates that over evolutionary time, these hominids have become more and more bipedal. So the next thing that you might want to do is you might want to visualize the data. And you can do that in Data Explorer. Just go up here and click on the Visualize tab. And once again, it's going to ask you what type of plot you want to make. And in this case, you want to make a scatter plot. And when you make a scatter plot, you need to define what the x-axis is. And the x-axis in this case is, once again, time. So that would be the earliest fossil. And then you want to choose the y-axis, which is the foramen magnum index, which is the thing that you tested just now. And it will give you a scatter plot. And one of the things that you will notice with the scatter plot is that it's just not terribly attractive, nor is it really very informative, because you can see the two axes, but these dots really just are dots. You can tell what the values are, but you can't tell what species they go to. And you can go down here and find other information, like you can add a regression line, and it will show you the plot of the regression line. So this is essentially showing you a plot of the regression line that has a slope of 2.22. But this is not a great sort of graph that you would want to present, because all you can tell is that the regression is positive. You don't have any idea what these species are. So what you might want to do instead is you might actually want to go back to Excel. So I'm going to go back to the folder that I have stored my data file in, assuming that I can get my computer to respond. So give me a sec to navigate there, and what we will see is in the place where I've been storing my work, I have the full data set here. And what we can do here is we can basically highlight the foramen magnum index column, and we can highlight the date of the earliest fossil. We can go up here and click on Insert, and we can ask it for a scatter plot. And what you're seeing now is you're seeing that the foramen magnum index is what is being plotted, and you can see that the x-axis is time from 4 million years ago to the present, and this is the value of the foramen magnum index. So I'm going to move all of this over so that we can see things a little better, and I'm going to make this bigger. But once again, you're probably saying to yourself, well, Dr. Klowinski, this is no better than the figure that we had a few minutes ago, and you would be correct. It's pretty rough. But what Excel allows you to do that HHMI Data Explorer does not is it allows you to clean things up and make things better. So among the things that you might want to do with this graph is you see that the y-axis is over here at 0, which is kind of the default way that you would do this. You have your y-axis labeling at 0. But since we're going back in time, we might want to have our y-axis at minus 4 million years. So you can go down here and click on the horizontal axis, and you can right-click, and you can basically format the axis. And when you do this, you will get a Format Axis pane that appears in the right-hand portion of your workspace here. And you want to go here and change the vertical axis crosses, the x-axis, and you want to change it from automatic to axis value, and then you want it to put a -4 in there. And then hit return, and you will see that now the labeling of the y-axis is over here on the far left-hand side, which then keeps it from covering up some of these points. Now, the next thing that you might want to do with all of these data is you might want to be able to label them by what species they are. So one of the things that you can do is for this chart, you can basically go to chart design up here at the top, and then for this chart, you can go over to the far left-hand side and click on this thing that says Add Chart Element. That will give you a drop-down box, a drop-down menu. And then in this, you can go to Data Labels. And then I like the Data Callouts. I like this one that's down here at the bottom. It's called Data Callouts. And when you click on that, it will give you these little labels that are, in this case, the coordinates of the data points. Now, once again, that's not terribly useful, and also these labels are covering up a lot of your data over here in the upper right-hand corner. But what you can do is you can click on these callouts and then go to label options over here, get rid of the X value and get rid of the Y value and click instead on value from cells. That's going to give you a little entry box here. And what you want to do now is you want to go over here and you essentially want to get the earliest fossil dates and highlight that range and then click OK. Oh, sorry, that's wrong. Back that up. You don't want to do that. You want to select instead the species codes because that tells you what species is which. Sorry, made a mistake there. So now you have a chart that shows you all of these species codes. But once again, there are some issues with this figure because some of these labels are actually on top of the points that you want to be able to see. But one of the things that you can do with these labels is you can just click on them and you can drag them out of the way. And when you drag them out of the way, you can now see which points these labels are actually pointing to. And so you can drag them around until you can actually see things clearly. And it may take a few minutes to get them positioned in the exact places that you want them to be, but because they're little call-out boxes, they actually have a little tail that points to the figure. So for example, down here, this is Homo neanderthalensis, and it's pointing to a point that is to the right here. And so what you might want to do is you might want to move Homo floresiensis' label over here and put Homo neanderthalensis label here. And so you can now have your points labeled so that anybody who looks at this figure can see which species is which, and you can also see where all the points are. Obviously, Homo neanderthalensis, Homo sapiens, these are all relatively recent hominids. These are the intermediate age hominids, and these are, of course, the earliest hominids. And then we have the Pan troglodytes and Pan paniscus here. At this point, what you might want to do is you might want to just change some things about the formatting of the axes so that you can read things a little better. You might want to get rid of this weird FMI title. And then if you go back to chart design, you can also do things like adding axis titles. You can add a title for the primary horizontal axis. You can then change the font size of that so that it's easier to read. And you can change the text, and you can just type in time before present. And this is in million years before present. And then you can go in and once again, go to chart design, go to add chart element, axis title, the vertical axis title. And in this case, once again, you might want to change the font so that it's a readable font. You know, it's big enough that it can be read. And then you can type in what the y-axis is, which in this case is the foramen magnum index. If you want to, you can get rid of grid lines. You can basically make lots of changes to your plot. Oh, the last thing that you might want to do is you might want to go in here and click on the points. And once you've clicked on the points, you can right-click. And when you right-click, you can basically add a trend line. And when you add a trend line, the default is going to be a linear trend line. And you can change things, once again, about the trend line itself. You can make it linear. You can change the type of line that it is. In this case, this is a weird dotted line. You can change the color of the line. You can change it to a solid line. You can alter the thickness of the line, et cetera, et cetera. But other things that you can do while you're doing this as well is you can basically go to the data tab here, and you can ask it to display the equation on the chart, and you can get it to display the R-square value. I'm going to grab this and drag it over here, and then I'm going to increase the font size here so that you can actually see that. And once again, you can see that it's the same regression equation that we calculated in HHMI Data Explorer. And the other advantage to this is it also tells you what the R-square value is, which is one of the measures of how well the data fit the line. Is there a lot of variation around the line, or is there very little variation around the line? And so as X changes, how does Y change, and how predictable are the changes in Y? And then at this point, you have a decent graph that you can just take a picture of, take a screen grab of, and you can put that into your post lab. So hopefully this will help you work through how to go through the data analysis. Keep in mind that your lab instructors are there to also help you work through all of this. And hopefully you will have your own hypothesis to test, because we've worked this one with you as part of the introduction to the lab. We want you to perform your own test of your own independent hypothesis. So that's it for this screencast, and I hope you have a smooth time in lab this week.